They say the universe is smooth, uniform, a perfect cosmic canvas stretching infinitely. They say the Big Bang forged a flawless reality, a single, unbroken expanse of space and time. But what if they're wrong? What if, in the first screaming microseconds of existence, the very fabric of reality tore itself apart, leaving behind monstrous invisible wounds? Imagine cracks so vast they dwarf galaxies, scars so profound they repel all matter, two-dimensional razors slicing through the heart of the cosmos. These aren't just theoretical curiosities. They are the universe's forbidden secrets, potential evidence that our reality isn't a seamless whole, but a terrifying fractured patchwork, stitched together with cosmic seams that could unravel everything at any moment. The universe wasn't born perfectly smooth. Oh no, it exploded into being. A furious, blinding inferno, hotter and denser than anything you could ever imagine. In those first incomprehensible fractions of a second, the cosmos was a seething, roiling soup of pure energy, a chaotic maelstrom where the very laws of physics were still forming, still deciding what they wanted to be. This primordial cauldron, a unified state of unimaginable power, began to cool with terrifying speed as space itself ripped outward. Think of it like boiling water. As it churns, the molecules zoom around, unbound, a single, unified state. But then, as the universe expanded, it cooled rapidly, catastrophically. And just like water chills into ice, the fundamental forces of nature, the very fabric of reality, began to freeze out. They underwent what physicists call phase transitions. This isn't just a simple metaphor. It's a violent, cataclysmic transformation. Imagine a cosmic ocean, once a single amorphous liquid, suddenly congealing, solidifying, its very essence crystallizing into distinct forms. Now here's where the terrifying truth emerges. The moment the universe doomed itself to potential fracture. When water freezes, it doesn't always form one perfectly uniform block of ice. No, it often cracks. It splinters. Different regions crystallize independently, their internal structures misaligned, settling into slightly different orientations. When these growing ice crystals collide, they don't merge seamlessly. They clash, they fracture, and where they meet, you find the irreparable flaws, the fault lines, the deep, unhealing seams. The early universe faced the same brutal dilemma, but on a scale that beggars belief. As the incredibly hot, unified forces of creation began to freeze into the distinct forces we know today, gravity, electromagnetism, the strong and weak nuclear forces, the underlying quantum fields had multiple choices for their lowest energy state, their fundamental configuration. Picture a landscape with several valleys. The universe, like a rolling ball, had to settle into one, but different parts of the universe, in their chaotic rapid cooling, plunged into different valleys, different vacua. One patch of nascent space might have settled into a particular quantum state, a specific energy minimum, while a neighboring patch locked into a subtly different one. These weren't conscious choices, of course, but the inevitable outcome of quantum randomness and the extreme energies present in an unimaginably energetic environment. And when these vast, independently frozen domains expanded and slammed into each other, they didn't just merge, they created boundaries, permanent, fundamental boundaries. Imagine two titanic, invisible tidal waves of quantum fields crashing head-on, their energies ripping apart the very dimensions, creating regions where the rules themselves warp and tear. These are the domain walls, immense, two-dimensional rips in the space-time fabric itself. They are the cosmic scars from the universe's violent, imperfect birth. They are not merely theoretical curiosities. They are the ultimate evidence that our reality, the reality you inhabit, might be fundamentally flawed, stitched together from different pieces that never quite fit. These aren't just minor cracks in the cosmic ice. These are razor-sharp chasms of pure energy, born of chaos, and destined to warp, repel, and ultimately reshape anything they touch. These primordial wounds, if they exist, scream a terrifying truth. The universe we thought we knew might be fundamentally broken from its very first breath. So if these cosmic scars, these domain walls, actually exist, what are they? What do they do? Forget everything you think you know about empty space. A domain wall isn't a void, it's not a vacuum. It's not even a black hole, it's a two-dimensional, infinitely thin, utterly alien entity. A razor's edge of pure concentrated energy, born from the universe's violent phase transitions. Imagine a sheet of pure force, thinner than a single proton, yet possessing the mass of entire galaxy clusters. It's a membrane of unimaginable density, a region where the very quantum fields that govern reality are stuck in an excited, unstable state, unable to settle into the comfortable, low-energy vacuum that defines our familiar universe. Picture a colossal, invisible pane of glass. But this glass isn't static. It's alive with immense latent energy, vibrating with the leftover trauma of creation. This isn't a boundary you can cross, not a place you can visit. It's a fundamental rip, a tear in the space-time fabric that defines existence on either side. Think of two immense cosmic credit cards, each representing a domain of our universe, but instead of magnetic strips, they have quantum fields encoded on their surfaces. Now imagine those cards pressing together, their edges meeting. That meeting point, that infinitely thin edge, that's your domain wall. It's the impossible boundary where two distinct, stable, vacuum states of the universe's fundamental fields violently collide. And this collision has horrifying consequences for everything we hold dear. Matter itself. The defining characteristic of a domain wall is its monstrous gravitational repulsion. Yes, repulsion, not attraction. Every other object in the universe, from a tiny dust motes to a supermassive black holes, attracts matter through gravity. Domain walls, however, actively push it away. They are cosmic anti-gravitational engines. This isn't just a slight nudge. It's an overwhelming, annihilating force. If a galaxy, if a star, if even a single atom drifted too close to a domain wall, it wouldn't be pulled in. It would be violently, mercilessly expelled. Imagine a cosmic snowplow, infinitely wide, infinitely tall, plowing through the universe. Everything in its path isn't absorbed. It's swept aside, repelled with unthinkable power. This means that if a domain wall exists, it would carve out vast, empty regions of space around itself, like a giant cosmic broom sweeping away all matter. These would be cosmic voids unlike any we know, not just areas where galaxies happen to be sparse, but active zones of expulsion, utterly devoid of stars, gas, or even dark matter, all violently pushed away by the wall's repulsive gravity. These aren't just empty spaces, they're forbidden spaces, regions where the universe itself screams, "Stay away." But the terror doesn't stop there. Because a domain wall is a region of incredibly high energy density, it would also warp space-time in profound and bizarre ways. Gravity is born from mass and energy, and a domain wall, despite being two-dimensional, packs the energy of 1,000 galaxies into an infinitesimal thickness. This means it would act like a colossal, invisible lens, bending light and distorting the views of distant objects in ways that defy normal gravitational effects. Imagine looking through a funhouse mirror, but the distortions are caused by a cosmic tear, not a trick of glass. Light from behind the wall would bend around it, creating strange lopsided images, or even multiple images of the same galaxy, stretched and smeared across the sky. Moreover, these walls wouldn't just sit still. Born of the early universe's rapid expansion, they would likely be immense, perhaps spanning billions of light years, and they would be moving. Imagine an invisible galactic-scale bulldozer pushing through the cosmos, clearing a path of absolute emptiness wherever it goes. And if one of these walls were to pass through our galaxy, our solar system, or even Earth itself, it wouldn't just disrupt things. It would be an extinction event beyond anything we can conceive. The repulsive force would violently tear apart planets, shatter stars, and scatter all matter into the cold, empty void, leaving nothing but a vast, lifeless expanse in its wake. It would be the ultimate cosmic erasure. The very idea of these domain walls forces us to confront a terrifying possibility, that the universe isn't just vast and mysterious, but that it might be fundamentally broken, scarred by its own violent birth. The hunt for these cosmic seams isn't just an academic exercise. It's a desperate search for evidence that our reality might be far more fragile, far more dangerous than we ever dared imagine. If this journey into the universe's hidden wounds has captivated your cosmic curiosity, then smash that like button and subscribe. You don't want to miss what else we uncover about the terrifying secrets lurking in the depths of space. So, if these terrifying domain walls are out there, vast and invisible, actively repelling matter and bending space-time, how in the name of all that is cosmic do we find them? It's not like we can just send a probe to poke at the edge of the universe. No, hunting for these primordial scars requires the most ingenious, indirect, and often desperate methods known to astrophysics. We become cosmic detectives, sifting through the universe's oldest light and its grandest structures for the faintest, most unsettling clues. Our first, best weapon in this cosmic manhunt is the ancient echo of the Big Bang itself, the cosmic microwave background radiation, or CMB. This is the universe's baby picture, light released just 380,000 years after creation, when the cosmos finally cooled enough to become transparent. It's a faint uniform glow across the entire sky, but it's not perfectly smooth. It has tiny, subtle temperature fluctuations, like ripples on a cosmic pond. These ripples are the imprints of the early universe's density variations, the seeds from which all galaxies and stars eventually grew. Now here's the crucial part. If a domain wall formed in those first moments, it would have ripped through this primordial plasma, leaving a distinct, horrifying fingerprint on the CMB. Imagine dragging a giant invisible comb through that cosmic pond. The wall's immense energy and repulsive gravity would have created a sharp, linear discontinuity in the CMB temperature. One side of the sky might show a slightly warmer or cooler band than the other, a sudden, inexplicable drop or rise in temperature stretching across billions of light years. It would be like finding a perfectly straight, unnaturally cold line etched across the universe's oldest photograph, a line that screams, "Something was here, something alien." Scientists are meticulously mapping the CMB with unprecedented precision, searching for these telltale straight lines, these impossible cosmic boundaries. But the CMB isn't our only clue. These domain walls, with their matter-repelling fury, would also leave monstrous voids in the grand tapestry of the universe. We already know about cosmic voids, vast, empty regions of space where galaxies are sparse, but these are usually formed by gravity slowly pulling matter into denser clusters, leaving behind underdense regions. A domain wall would create something far more dramatic, far more unnatural. It would carve out a perfectly linear, perfectly empty corridor, a cosmic exclusion zone where no galaxy, no star, no even dark matter could ever exist. Imagine looking at a map of all the galaxies in the universe. They tend to cluster into immense cosmic webs and filaments, with vast, irregular bubbles of emptiness in between. But if a domain wall were present, you wouldn't see an irregular bubble. You would see an impossibly straight, utterly barren trench, a cosmic desert stretching for billions of light years, completely devoid of light, matter, or life. Astronomers are building 3D maps of the universe, plotting the positions of millions of galaxies, searching for these impossible straight lines of absolute nothingness. Finding such a linear void would be like discovering a perfectly straight, razor-sharp canyon carved into a mountain range by an unknown, impossible force. Then there's the bizarre effect on light itself. A domain wall's immense energy and space-time warping power would act like a colossal, invisible lens, but a lens that distorts reality in ways no ordinary mass can. We call this gravitational lensing. Massive objects bend light, allowing us to see distorted or multiple images of distant galaxies. But a domain wall would create a unique, highly specific lensing signature. It wouldn't just magnify or stretch images. It would create strange asymmetric distortions, or even split a single distant galaxy into two identical images that are perfectly symmetrical across an invisible line. It would be a cosmic optical illusion, a funhouse mirror effect caused by a tear in reality, revealing the presence of something that repels rather than attracts. Telescopes like Hubble and the James Webb Space Telescope are constantly observing distant galaxies, looking for these impossible lensing patterns, these ghostly reflections of a universe warped by an unseen razor. Finally, and perhaps most chillingly, scientists are searching for subtle, almost imperceptible shifts in the fundamental constants of nature. If our universe is indeed a patchwork of different domains, each with slightly different vacuum states, then the physical laws themselves might subtly vary across these cosmic boundaries. The strength of gravity, the mass of an electron, the speed of light, these constants, which we assume are universal, might actually shift by a tiny measurable amount. If we were to cross into a different domain, it would be like stepping from one room to another, only to find that gravity is suddenly 0.0001% weaker, or that light travels a fraction of a millimeter per second faster. These are incredibly difficult measurements, but they represent the ultimate confirmation that the very rules of reality are not fixed, but vary across these cosmic scars. The hunt for domain walls is a hunt for the universe's deepest, most fundamental flaws. It's a search that could shatter our understanding of cosmic origins, revealing a reality that is not merely vast and mysterious, but fundamentally broken, stitched together from different pieces that never quite fit. And if we find them, if these cosmic seams truly exist, it means the universe we thought we knew is a far more fragile, far more terrifying place than we ever dared imagine. If you're still with me, if your mind is reeling from these possibilities, hit that like button and subscribe to the channel. We're just scratching the surface of the universe's most unsettling secrets, and you won't want to miss what comes next. So, imagine the impossible. We find one. A perfectly straight, utterly barren trench in the galaxy distribution, a sharp, linear discontinuity in the cosmic microwave background, a bizarre, asymmetric gravitational lensing effect that screams repulsion. The evidence is undeniable. A domain wall, a seam in the universe. What then? The discovery would unleash a maelstrom of scientific and existential shockwaves, shattering every cosmological model, every assumption about the fundamental nature of reality. First, our understanding of the Big Bang itself would be irrevocably rewritten. The prevailing theory, inflation, posits a period of exponential expansion in the early universe that smoothed out any imperfections, ensuring the universe we see is vast, flat, and uniform. A domain wall, by its very nature, is a profound, large-scale imperfection. Its existence would mean that either inflation never happened or it failed spectacularly in some regions, leaving behind these monstrous scars. The entire narrative of cosmic origins, the very genesis story of everything, would be ripped apart and reassembled, potentially revealing a Big Bang far more chaotic, far more violent than we ever conceived. We'd have to confront the terrifying notion that our universe was born not from a single, perfect event, but from a messy, fractured process that left behind colossal, unhealing wounds. Then there's the sheer, mind-bending scale. If even one such wall exists, it implies a universe far larger, far stranger than our observable bubble. These walls are cosmic boundaries between different vacuum states, different fundamental configurations of reality. That means on the other side of that wall, beyond that razor-thin seam, the laws of physics themselves might be subtly or even radically different. Imagine crossing an invisible line, and suddenly, gravity is a tiny bit stronger, or light travels a hair faster, or electrons behave in ways that would shatter our quantum mechanics textbooks. The discovery of a domain wall wouldn't just be finding a new cosmic structure, it would be finding definitive proof of a multiverse, not of parallel universes layered on top of ours, but of distinct, adjacent realities, separated by an infinitely thin, infinitely powerful barrier. Our universe would be revealed as just one patch in a vast cosmic quilt, stitched together from different fabrics, with the seams exposed. And what about the existential dread? A domain wall isn't just a scientific curiosity, it's a terrifying, active threat. Its repulsive gravity means it continuously pushes away all matter. If such a wall were to traverse our galaxy, it wouldn't be a gentle passing. It would be a cataclysmic, universe-altering event. Our solar system, our stars, our planets, all matter would be violently ejected, scattered into the cold, empty vacuum. The very ground beneath your feet, the air you breathe, the atoms in your body, all would be ripped apart, flung outwards by an unstoppable, anti-gravitational force. It wouldn't be a collision, it would be an erasure, a cleansing of space, leaving nothing but a vast, silent emptiness where our vibrant galaxy, once pulsed with life. The discovery would force humanity to confront its ultimate vulnerability. We already live on a tiny speck in a vast cosmos, subject to asteroid impacts and stellar explosions. But a domain wall introduces a new, incomprehensible scale of danger. It would be an omnipresent, invisible sword of Damocles, hanging over all existence, a constant reminder that the universe, born imperfectly, could unravel at any moment or simply sweep us aside like cosmic dust. The very concept of safe would be obliterated. Every moment would be a borrowed one, lived in a universe potentially scarred and destined for violent fragmentation. Moreover, the implications for life and consciousness would be profound. If the universe is indeed a patchwork of domains, each with slightly different physical laws, then what does that say about the uniqueness of our existence? Are there other forms of life, other intelligences, on the other side of these walls, living under entirely alien physical rules? Or are those domains simply barren, hostile to any form of organization, forever separated from our reality by an impassable, matter-repelling barrier? The search for extraterrestrial life would gain an entirely new, terrifying dimension as we realize that the greatest barriers to communication might not be distance, but fundamental differences in the very fabric of reality. The finding of a domain wall would not just be a scientific discovery, it would be a revelation. It would force us to abandon our comfortable illusions of a perfectly formed, predictable cosmos. It would confront us with the raw, terrifying truth of a universe born of chaos, bearing the unhealing scars of its violent genesis, and potentially destined for a future of fragmentation. It would be the ultimate proof that our reality is not a pristine, seamless tapestry, but a cosmic Frankenstein's monster, stitched together from disparate parts, with the seams showing and the potential for a catastrophic unraveling ever present. The search for seams in the universe is more than a scientific pursuit. It's a profound, existential gamble. It forces us to confront the deepest, most unsettling questions about our cosmic origins, about the very fabric of reality, and about our place within a cosmos that might be fundamentally, terrifyingly flawed. If these domain walls exist, they are both a testament to the universe's unimaginably violent birth and a chilling reminder of its potential fragility. They would reveal a cosmos not as a monolithic, perfectly forged entity, but as a vast fractured tapestry, stitched together from disparate pieces, bearing the unhealing scars of its chaotic creation. This isn't just about finding another exotic object in space. It's about uncovering a truth that shatters our illusions of order, exposing a universe where the rules themselves are not universal, but locally defined, separated by razor-thin boundaries of pure, repulsive energy. The awe lies in the universe's capacity for such monumental, terrifying structures, born from the very quantum mechanics that underpin our existence. The dread comes from the realization that our perfectly ordered reality might just be one domain among countless others, and that the boundaries separating them could be colossal, moving walls of annihilation. It means we might be living on a borrowed patch of stability, forever unaware of the immense, matter-repelling chasms that could be carving out emptiness just beyond our sight, or even hurtling silently towards us. Ultimately, the quest for these cosmic seams transforms our understanding of reality. It shifts us from inhabitants of a single coherent universe to potential denizens of a fractured multiverse, where the laws of physics are not immutable truths, but localized agreements, and where the greatest dangers might not come from distant stars, but from the very fabric of space and time, tearing itself apart. It's a terrifying, yet exhilarating reminder that the universe holds secrets far stranger, far more profound, and far more dangerous than we can possibly imagine. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.